You complete me. And I just had...
Shut up. Just shut up. You had me at hello. You had me at hello.
Wow, that was adorable. I can't imagine there's a dry eye out there right now. Famous movie clip from Jerry Maguire. You complete me. Obviously, we're completing the square. It made me think of that. I've actually never seen the movie Jerry Maguire, but can you guess which algebro, that's their favorite movie? If you had to guess between all the algebros, whose favorite movie is it? Maybe this little tweeter here will help you out here. So here's a tweet from Mr. Kelly. There it is. I love Jerry Maguire. Probs, my favorite rom-com. Who uses probs? Instead of probably. Unreal. Romantic comedy, rom-com. Yeah, you complete me, Mr. Kelly. Well played. So that's his favorite movie of all time. And that's what we're going to be doing. We're going to be completing the square here. So let's get to it. Completing the square. How do we do it? Let's jump. Alright, so how do we complete the square? Here it is. It's going to happen fast. Be careful. How do we do it? Boom, there it is. I just completed the square right there. Unbelievable. Completing the square. Done and done. Shortest video ever. I think broke a record there. Alright, let's get to it here. Let's solve some of these. So, before we complete the square, let's make sure we know what we're talking about by the square. We're talking about perfect squares here. So remember, this squared up here means you're multiplying it by itself. So we're really saying x plus 4 times x plus 4. And then it's a matter of distribution here. You're going to distribute, it's like a double distribute. So we've done this, and I know we did a little bit with Mr. Sullivan in the last one. You've got x squared plus 4x, and these are these special cases. When I distribute the next one, I've got another 4x plus 16. So we've got the same thing twice, so what happens, that middle term turns into 8x, and that last term is 16. So these are those perfect square trinomials that you were looking for, those special cases, and that's a perfect square. Awesome. Does it work with negatives too? Sure. If you square a negative, it means you're multiplying it by itself. So you're doing the same thing. And then what happens, you're going to do a double distribution here, or some teachers like to call it FOIL. We're really saying x times x is x squared, minus that 5x, and then you're going to minus another 5x. So that middle term is the same, and then plus the 25 on the outside. So when I look at this, I'm going to get that minus 10x in the middle, plus the 25, so I'm good to go. So these are the perfect squares when you multiply by itself. So how does that come in handy? It's going to be huge. It's actually a really nice way to solve equations, and that's what we're kind of building up to. The idea is, can you recognize this? This is a perfect square. Well, what is it? Well, look what happened here. You know, this 4 turned into an 8. This 5, negative 5, turned into a negative 10. So really what's happening here, hopefully you can recognize it, this is going to be x plus 3 squared. And it makes sense when 3 squared is 9, and then 3 plus 3 is 6. So when you have that going on, you're good to go. If you multiply that out, distribute it out, you're going to get that. So if I look at this one right here, I'm looking at 7. Looking at 14. Get ahead of myself. What's half of 14? It is 7. And when I square it, is it 49? Sure. So that is a perfect square right there. We're good to go. So that's cool. So how's that going to help us solve equations? Let's scroll down a little bit here. If I got this equation here and I say, oh, check that out. That's a perfect square. I know, I just did it above, that this is x plus 3 squared equals 100. Can I solve this equation now if I have that perfect square? Sure. What do? You square root both sides. So this turns into x plus 3. The square root cancels the square. Square root of 100 is 10, and then check that out. You can solve it. Ooh, what happens though when you introduce the square root? It's plus or minus 10. So we'll subtract our 3 from both sides. We're looking at x equals negative 3 plus or minus 10. So we're going to go ahead and simplify that out. If I have that negative 3 plus 10, I'm looking at 7. Negative 3 minus 10 is negative 13. So it's two solutions. These are the roots. This is where it's crossing the x-axis. That's the solution. I love it. All the same stuff there. A lot of different words for the same thing. Cool. How about this one over here? So it's the same perfect square above. I recognize that that was x minus 7 squared. And that equals 5. And then what am I going to do? I'm going to square root both sides. So boom, square root both sides. So this is nice. Square root cancels the square. Oh, but check this out. That is plus or minus square root of 5. I don't know at this time. So what does this mean here? I'm going to say, what? Add 7 to both sides. So I add my 7. And then what's left? I'm going to have x equals 7 plus or minus the square root of 5. So we're going to leave it as an exact answer, no decimals here. You can leave it just like this. If you want to split it to 7 plus radical 5, if you want, remember that means the same thing, or 7 minus radical 5. Those are my two answers, but you can leave it as this would be a great way to express it. Cool. So that's how we're going to use this to solve equations. So what happens if we don't have a perfect square? I mean, most things aren't when you run into them, you're solving something. It's not going to be a perfect square. Can we make things perfect squares? Sure. If I add a number here at the end, what is this number going to be here so it is a perfect square? Well, what's the rule here? We were cutting that in half, weren't we? That's going to be, excuse me, cut that in half is 2, square it, and then I add a plus 4 out here. So that question mark turns into a plus 4. Is that thick enough right there? Plus 4. So you're adding 4 to both sides. So really, I can make perfect squares. Same thing here. I want to make this a perfect square. Just cut that bad boy in half. So I'm looking at 8 squared, and then 8 times 8 is what? 64. So you're going to add this number on the end here. So we can always add or subtract things. Like, how does that relate to equations? Well, if I'm solving an equation, I'm going to take everything that has an x and leave it on one side, move everything else to the other side. So let's move this bad boy over so they cancel. So we're really looking at x squared minus 12x equals negative 5. So can I make this a perfect square? Sure. We're kind of saying, okay, I'm looking at this area here, x squared minus 12x. I'm going to do the same thing I kind of did above there, where I'm like, what is this question mark? What can I add to make this a perfect square? So we can add anything we want. In this case, what do I really want to add? Well, it's negative 12x in the middle. So I'm going to say, cut that bad boy in half, x minus 6. So what am I adding? Well, 6 times 6 is 36. I'm really adding 36 to both sides. So if I do it to both sides, it's legit. Remember, this is an equal sign. Whatever you do to one side, you got to do it to the other. So I added 36 to the left side. Just add the right side, and it's still equal. No problems. So what happens on this? Negative 5 plus 36 is 31. Now this is my equation I have to solve here. So we completed the square just for the fact that now we can solve it. So now we're at the point where we're saying, oh yeah, I can solve this. Just square root both sides. We're looking at x minus 6 equals, again, plus or minus. I introduced that, the square root of 31. So what do you do here? You got to add 6 to both sides. Oh, I love it, completing the square. So this is going to turn into 6 plus or minus the square root of 31. So we're getting kind of these weird looking answers, but I think hopefully we're getting used to them by now, and we're good to go. So completing the square, huge way to solve some equations. Love it. Alright, so how about a formal rule here for all, if you like the formal rule? If you're going to complete a square, you've got x squared plus bx. So what were we doing? We were cutting b in half. So all you have to do is add b cut in half and then square it. So this is what we're adding to both sides of the equation. So if you want to complete the square, you're going to add that. Let's just do it. So again, when I start this off, I go ahead and move anything that doesn't have a variable in it. So all my x's are on the left, so let's leave them over here. 2x squared plus 12x, and I like to leave a little room here, a little space, equals negative 30, and I kind of left myself a little space here to complete the square. Key is here, I can only complete the square when the leading coefficient is 1, or when this is, I can't have a number in front of the x squared. So what do I have to do? I'm actually going to have to factor that out here. So I'm going to factor that bad boy out, and I'm left with 2, I'm sorry, the 2x squared divided by 2 is x squared plus 6x. So I just pulled out the greatest common factor, still equals negative 30 over here. And then now I'm going to actually complete the square. So I'm going to complete the square here. And so how am I going to do that? I'm going to say x plus 3, half of this. Then I'm going to add that in there. What do I add in when I square it is b. So that's that b divided by 2 is 3, squared is 9. But this 2 comes down. Remember, I factored that 2 out. So it comes down. So I'm squaring this, and it still equals something over here. But check this out. So I added 9 over here. Do I add 9 over here? That'd be nice, but be careful because check out this 2 in front. This is actually got to distribute in here. You actually added 18, not 9. The most common mistake right here, it's 2 times 9, so you're actually adding 18 to both sides. Looks like 9, but it's not. It's double 9. So make sure you take that into account. So when I do this, I'm left with what? I'm left with negative 12. And now I'm ready to solve this equation. This equation is a little bit harder. Remember, I got to get the perfect square by itself, so I'm actually going to divide this boy by 2 to start. And now I'm left with just that perfect square, which is awesome. So it equals negative 6. And then what do I do here? You know, I'm going to square root both sides. Ooh, I like this one. What happens over here? I've got this x plus 3 equals, what is this? Oh, it's imaginary. You can't square root a negative unless you introduce these imaginary numbers. So this will actually be plus or minus I radical 6. Oh, I love it. Let's finish it out here. So what I got to do both sides, I'm going to subtract 3. And that's going to get x by itself. So I'm looking at negative 3 plus or minus I radical 6. Holy cow, that's an answer right there. Love it. Love it. How about the next one? I'm going with some special cases here. Is this going to freak you out? It's actually all set up for you, which is great. I've got only x's on the left. So I'm ready to do my little perfect square thing. You know, I like to leave a little space. And I'm going to do my little perfect square here. So what's going to happen? So down here I'm going to say, okay, I'll take this. I'm going to take my b term here and cut in half. So, oh no, fractions. Don't freak out. If you got to use decimals, use decimal. No worry. I'm going to leave mine in fractions though. But if you want to call it 2.5, no worries. So what happens here? You've got half a b. Then you're going to square it. So what is that squared? That's going to be plus 5 squared is 25. 2 squared is 4. You're actually adding 25 fourths to both sides. So whatever you do one side, you got to do it to the other side. Holy cow. So what does this equal? Well, we're going to say 7 fourths. 7 plus 25 fourths. So if you want to make this fourths, you're really saying, make this 4 times bigger. 28 fourths plus 25 fourths is what? If I put these two together, I'm looking at 53 fourths. So again, if you had to go decimals, that's fine. I'm gonna keep this fraction going though. I like the fractions. I like it. Kind of hard to read that. Let me try that again here. So what would I say that was? 53 fourths? 53 fourths. Awesome. So now let's solve it. So I'm ready to square root both sides. Square root both sides. So I'm looking at x minus 5 halves equals plus or minus the square root of 53 over 4. Excellent. And now I'm going to go ahead and say what? I have to add 5 halves to both sides. So I'm going to add those 5 halves. Add those 5 halves. So I'm looking at x equals 5 halves plus or minus the square root of 53 over 4. So it looks like a mess there. Can we simplify it? Yeah, we can actually simplify this a little bit. Remember, if you've got a square root of everything, it actually means the square root of the top over the square root of the bottom. And why is that good for us? Well, if I'm doing this, I can say 5 halves equals what? Plus or minus the square root of 53 over, what's the square root of 4? It's just 2. So the top's not going to break down. I don't think anything divides 53 to reduce that. So this is my final answer here. And it's a nice exact value. I'm good to go on that. So don't freak out about fractions. You can do them. Just keep working with them. Simplify them down. Awesome. We're killing it. All right, so let's tie all this into graphing because that's really, I think we'll tie it all together for us here. So vertex form is a nice way. I've got a parabola here in standard form. Problem with standard form is I can't tell what the vertex is. So say I wanted to graph this thing, can't do it in this. Well, I can do it in this form, but a nice way to do it is look at it in vertex form. So let's do that. Completing square is going to help us out here. If I subtract 21 from both sides, so again, I want to get all my x's on one side. So I'm really looking at y minus 21. Equals that x squared plus 10x. So now I'm all set to complete the square. So we can really complete the square for anything here. So how do I do this? So I'm looking at what? I'm going to take that b term, cut it in half, so it's going to be 5. Square it. So I'm actually adding 25 to both sides. So whatever you do one side, you got to do it to the other side. So when I do that, I've got y, plus 4, negative 21 plus 25 is that 4. Equals this. So that's awesome. So how do I do this? Well, just subtract 4 from both sides of the equation, and we're really looking at y equals x plus 5 squared minus 4. So boom, we've got the vertex. We're good to go. That's vertex form. We can plot that on there. Remember, it's opposite of what you think in the parentheses. You're going to go left 5, down 4. We're looking at this. And you could do your 1, 3, 5 rule from here if you want, which is a great little rule. 1, 2, 3 over 1. Ooh, and that works out nice for us, doesn't it? And then we could do our 1, 2, 3, 4, 5 up here and over here. So that's a great way to do it. But it says find the roots, so we're looking for those x-intercepts. We lucked out on this one, didn't we? Like I just graphed them. But let's say I didn't know that. Could I do that? Could I solve that algebraically? Sure. Just set it back equal to 0. So we're actually saying, hey, when does this equal 0? So if I had to solve this, just add the 4 to both sides. We've got 4 equals, and it's kind of tying into what we were doing last time. And now we're going to square both sides. So get the x squared by itself. We're looking at plus or minus 2 equals x plus 5. And then I'm going to subtract the 5 from both sides. So those cancel. And I'm looking at what? Negative 5 plus or minus 2 equals x. And again, that's saying like -5 plus 2 or -5 minus 2. So we're looking at -3 and -7 are my two roots. Did that match up? Sure, -3 and 7. So I did hit it. I lucked out with my 1-3-5 rule, showed it to me. Not always going to happen like that, but it could happen as a nice friendly answer. But we are going to get some crazy decimals here. All right, let's take a look at the next one here. So I want to start this one for you, then have you guys pause it and then finish it and see what happens. Hopefully it goes well for you. So if we're going to put this in vertex form, it's the same old, same old. You know, I want to get rid of the constants or anything without the x, move it over to the other side. So I've got this y plus 31 equals this, and it looks like I'm good to go. Like I'm ready to complete the square. I've got the spot for it, but be careful. You know, we can't have this leading coefficient be negative. Can't have this first term with a negative sign in front. So what are we going to do? So we have to factor this negative out here. So we're going to take that, pull out the greatest common factor, which is this negative. So negative x squared becomes positive x squared. This positive 12x becomes negative 12x, and give myself a little bit of room here so we can complete that square. And it still equals y plus 31. So now we're ready to complete the square. So give it a shot, pause it, see how it goes. Just make sure you keep that negative in count the whole way through. See if you can finish it, graph it. Good luck. Alright, here we go. Here are the answers. The key to this whole thing was that negative. Remember, when you add that 36, that negative distributes to it. So you're actually subtracting 36 from both sides. Subtract 36. Hopefully you took that into account so your signs are okay. Vertex is going to turn out to be at over 6 up 5. I know it opens down because of that negative in front. I actually even found the roots here. So again, this is the key. Right here are the roots. So this is actually going to be 6 minus radical 5. And I want you to label it on the graph. I don't want you to freak out by that. It's just a decimal. Type in your calculator if you want. You know, it's going to be 3 point something, blah, 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 blah. Again, here's the other root right here, and it barely fits on the graph. This should be 6 plus radical 5. So radical 5 is going to be like, what, 2 point something? So that's going to be 8 point something in there. And that's why that's 3 point something down there. So make sure you label them. I know you know these crazy numbers are the roots, the solutions, exact answers. We're good to go. Awesome. The finale, the last one right here. And again, I think I'm going to do the same thing. Just kind of set you up, get you in the right track, make sure you're okay with this. So go ahead and start solving it. You know, same old here. We're going to subtract the constant from both sides. I've got 2x squared plus 16x. And again, it looks like I'm ready to complete the square, except for what? Ooh, leading coefficient. Can't have that, so we're going to factor out a 2. So we've got x squared plus 8x. And then give yourself some room here to complete that square. So go ahead and finish this out. Go ahead and find it, find the roots, graph it, see how it goes. Good luck. Alright, so a lot going on in this problem. Hopefully when you're completing this square that, you know, when you brought the 16 up over here, that you make sure that you're not adding 16 to both sides. It's 2 times 16. So you're really adding 32 to both sides. So you should come up with this equation down here as a vertex form of this parabola. So you can mark the vertexes at -4, -12 down here. So there's my vertex at -4, -12. So I'm good to go there. How about the roots? So set equal to 0, solve. You can follow through the steps there, so this works out nicely. You get this -4 plus or minus radical 6. So I went ahead and typed that in the calculator so I can see the decimal form, but I want to make sure you can label these on the graph. So this is what? This is -4 minus radical 6. So that's the exact value of that point. It's really -6.449, blah, blah, blah. This root over here, this x-intercept, is going to be -4 plus radical 6. And the approximate decimal value is -1.55. So I also did the 1-3-5 rule, but in this case, you know, it's doubled, so it's 2, 6, 10. So I got a lot of points on there, a lot of good stuff. Hopefully you got that right. Awesome. Alright, so I've kind of noticed, you know, sounding off here. It seems, you know, after a while on these videos, I kind of say, peace out when I'm done, and I like that. So I was trying to think, you know, which algebra has the best sound off here. So I thought, you know, we got the comment section down there at the bottom. Let's add the comments. Let's put in there. Let's make it to a vote. Who's got the best sound off? So when I end it, I usually say peace out. I'm going to have these the algebras run through their sound off and then let you guys vote. So start us off there, Mr. Kelly. Give us your sound off, please.
Hey, this is Mr. Kelly sounding off here. Remember, it's nice to be good looking, but it's good to look nice. Peace! This is Mr. Sullivan sounding off here. Catch you on the flip side. Go Raiders! Hey, this is Spencer Bean, and I haven't made any videos yet, but I thought I'd practice a few of my sign-offs here. I was thinking maybe going funny, like, hey guys, it's Bean Real. Get it? Mr. Bean, it's Bean Real. Alright, maybe if I explain it's not good. How about serious? I hope you enjoyed the contents of this math video that I provided for you. Ooh, too serious. How about crazy? I love Flip Mastery! Yeah! Ah! Ah! No, that's too crazy for me. How about motivational? This is probably my favorite motivational quote of all time. I let kids fail because I care. Yeah, I think that's it. Woo!
Alright, so there are the other guy's sound off. Mr. Bean doesn't really seem to have one yet. If you want in the comment section to add a sound off you think Mr. Bean should use, let's take that too. So vote for your favorite one. Again, it's not about teaching. It's not about who your favorite teacher is, anything like that. It's about what's the best sound off. So only go with that. If you got an idea for Mr. Bean, maybe he'll use it. Maybe he'll use it if he ever makes a video. Maybe we'll put that in there. So good luck on the mastery check. Peace out.